Hello GameMakers, this is GameMaker Rob, and in today's episode we cover animating. We can now move to a character, choose an attack, watch the current actor play his animation, and then see the victim play their animation as well. We also have spells where we can cast a spell over 5 tiles. You can have it, over 20 tiles, however big you want. It'll all work the same. And we'll see every tile be animated, as well as any actors being hit by the spell as well. So let's get started. We now have sprites for all of the characters for all of the states. There are actually 5 states now. So we have, I'll show you. Each of these characters has an idle state, attack state, spell state, item state, and a hurt state. Most of them are pretty self-explanatory. If you make an attack or cast a spell or use an item, the character gets switched to whatever sprite is relevant, and an animation will play. Although this one plays, you won't really see it because it's just one frame. But on some of the characters, like the fighter, I've given them just some kind of like a progress bar animation to make sure that it works. Idle is, so whenever I see a tactics game and the units are waiting for their turn, they're kind of moving, or they're walking on the spot. So and it's the same animation really for when they move around as well. So idle and moving is going to be the same thing in this game. So if the character is moving around or they're idle, they're going to be using the same sprites for that. I haven't done any animations for these, so you won't see that in the game. And the last one is hurt. So if a character is hurt by a spell, then they get these animations. Although I think it was the knight that I gave an animation to for that. Yeah, so I just gave one animation to the knight so I can see that it works in the game. Although I just remembered that I should probably have another animation for being healed, but I think we'll do that for next episode. Bit too late to include that now. Okie doke. I just wanted to explain how we get the animations to run in order as well. So what we're going to do is we're going to be making use of our animation object, and inside the object we're going to have a queue, and we're going to fill that queue with lists. Each list is an animation. It's going to hold a script that we want to run. It's going to hold either a node or an actor instance ID that we want to animate. And for the actors, we're going to tell it what state to animate. For the nodes, we don't need to because it's just going to be a spell sprite that they're going to run. And then once that queue has been filled, the initialization part has been done, and we're just going to play those lists one by one. So the object will check to see what state it is. If it's in the state where it needs to get the next animation, it'll grab the list, it'll check what script to run, it'll run that script with whatever actor or node if it wants to affect, and then we'll see that happen. I also added a timer to make a pause between animations, otherwise it goes a bit too fast. And then once everything's played out for that particular animation, the state will change back to where the animation object can then get the next list from the queue. Once the queue is empty, that means all the animations have been played, and we can get the next actor because the current actor's turn is going to be done. That's the way I've decided to do it. Once you make an attack or use an item, something like that, your turn is over. So say, for example, we cast a spell and it's going to affect 5 tiles. So the first animation is going to be the current actor casting the spell. That's animation 1. Then animations 2, to 6 are going to be each of the 5 tiles being affected. If there's any characters in those tiles, which there should be, each of those characters is going to be an extra animation. So if tile 2 has a character, what's going to happen is the current actor animation will play, then the first tile animation will play, then the second tile animation will play, and then the character on that tile will play their animation before we proceed to tile 3. So that's how it's going to work. I just wanted to kind of explain it before we get into the nitty-gritty. And also, one small thing we've done is we now have an array for every actor that's going to hold their stats, because we don't want to modify our character grid, our character and classes grid during the battle, because we would be changing the classes, the base class stats, which we definitely don't want to do. So that's the main reason why, really. I just wanted to show you the spell animation. This is the Sprites. It's SPR, ISO, spell, anim, and it just plays these sprites in order, and that's it. Just kind of a flashing rectangular cube. Yeah, so this, including all the sprites for each character, is kind of time consuming. What I could do is I could include all of the sprites into a sprite sheet, and all you would need to do is, if you had all of these empty, you could just import them all, and they should be in the correct order. You don't have to necessarily put them into groups, because that's going to be time consuming. As long as you import the sprites and they're all in the correct order, then you're good to go. The game should run. If anyone has any difficulty or trouble with that, let me know, and I'll see what I can do in helping you out. Okay, so let's go into the create event of OBJ main, and in setup sprite grids, I've updated E actor sprites. One thing to note is we don't have move in here anymore, although you could just type move instead of idle, because it's the same thing basically in the game as I just explained at the start. What I needed to do is I needed to make sure the entries or the numerators inside eActor sprites matched eBattle menu. So attack is number 2 in eActor sprites, which matches battle menu. Then you have spell, item, and because this entry here, number 6 or number 5, sorry, 0, 1, 2, 3, 4, 5, because this entry is choose facing, we can use that for the hurt state for the actors. So that's what I have done. I was going to just get rid of this state, and that's how I started to do it, but then I thought it would be a bit confusing for people to see states being set to eBattle menu, and then we'd have to set the state to choose facing to play the hurt animation. So that's why I decided to just update this state anyway. Then we have updated our for loop to make sure we're including all of our new sprites. We've got a start and end variable for because we want to include every action for each character, so that's what this is for. And we have 4 facings. Create the grid, double for loop to add each sprite to the grid, the correct grid position for each character, and then add that character's grid to the global list that holds all of the characters' grids. It's the same as this before, but it just I put a note to say if you have animations for the states like movement, add them here, but that I don't think that would have really worked properly, because you need to do this. So this now will work for lots of different states. So this is the new code. And that's going to be it for the create event of obj main. Another change we have is with our script SCR army screen draw unit. Before we were only drawing one animation or one state, sorry, the idle state. But we need, if we want to use this script for drawing as before, then we want to make sure it works for all states. So we're going to pass two new variables to it. We're going to pass action, so what state or what action do we want the character to draw, and the image index of the action, so what index of the image do we want to draw. And you'll see we when we're drawing the sprite here, we're using index here to make sure we can actually play the animation. So here's the two new variables. We've updated this line to this line to get the sprite, and that's all the changes. Because we've done that, we actually need to press Control Shift and F and do a search for SCR army screen. That'll do. Find all, and then in every entry apart from the first one, because the first one is the actual script, just double click, it'll take you to the correct entry. So this one is in the draw GUI of obj army screen, the line 19. We've added the action, which is move, and the index is 0. What this means at the moment is the army screen is still going to draw static images. It's something we're going to do later on. Then the next one, same event, line 37, same changes. And then same event, line 91, same changes. And then in obj shop, draw GUI, line 70, same changes. obj test, draw at line 113, draw event. So this one we are passing it the active state. So what's happening here is we are drawing all of the units on the battle map, and instead of just drawing the idle state, we're passing it the active state and the actor's image index. So this will animate this time. So if we have like a moving walking animation, this will actually play on the battle map. Same event, line 144. This doesn't. Oh, okay, so I split this into two lines just to make it a bit easier to read. This is the full line. It's quite long, so I've just pressed enter to split it into two. So we have the current actor, the actor's ID. This is the same as before, and then we're passing it the current actor's state and the current actor's image index. Then same event. No, it's not. We're in the draw GUI now for obj test, line 90, passing it move state and 0 for index, and same event, line 129, same changes. Okay, so now we're going to go into the create event of obj test. Small change to e-battle. We've got a new state called running action. Nothing actually happens in this state. It's just to make sure that player input doesn't work while animations are playing. So that's all it's for, really. The next thing we're going to do is we're going to go into the end step, and we're just going to do a few things for the stats arrays for each actor before we do the animation stuff. So if we go into obj test end step and then set up battle, then create an instance for this unit, and then create stats. So this region here is new. So we have a for loop, and all we do is for every actor we run a for loop. As long as it's not name, then we want the real value of the stat, because they're all going to be numbers. If it is name, then we're just going to have the string value of it. And that's all we need to do to get an array for each actor. Then when we are in battle, in next actor, fill battle menu lists. So instead of using global.characterStats to get the item, we're just going to get it from the actor. And is that it for this? Then so we're inside actor taking turn, pick an action from the menu, awaiting action, and pressed enter. So inside where we check to see if selected option is attack, spell, or item, and that we have selected a secondary option inside here, we want to make sure the character has enough mana to cast a spell. So mana cost is going to say how much does this item cost to use. Most of the items are going to be 0, but if they are a spell, they should have a value greater than 0. Otherwise, the spell is free. As long as mana cost is less than or equal to the current actor's current mana pool, which is stored in their stats array, then remove that mana from their mana pool and allow them to take the action. If they can't cast a spell, nothing is going to happen. In order to have items with more than one charge, we would need every character in the player's army to have their own inventory grid or inventory array. The changes needed, I thought, kind of a bit too much. I'm trying to keep this tutorial as simple as possible. It's not a simple tutorial, but it could be a lot more complicated. So what I decided to do is just have items which were unlimited or items that have one charge only. And then if it has one charge only and we use it, then we just get rid of it. So that's what this is for. We're just checking to see how many charges the item has. If it's 1, then get rid of it. That's all it does. It doesn't matter if the character has 2 items of the same type in 2 different slots, because they'll never see in the game which slot has the item. So if they have 2 items, 2 healing potions, and they use the second one, they'll still see only 1 potion remaining in their item's action, but not which hand it's in. So it's not a big problem. So we've chosen from attack, spell, or item. We want to then be in the region where we press enter after choosing a secondary menu option. Move the unit. So instead of having changing the state to the character to moving, we're just going to have a boolean called moving, which is going to be set to true when they are moving. Because all we're going to use the states for now is for drawing sprites. So it was just easier to do it this way. That's it for move the unit. Then in perform attack, spell, or item. So we've got a new region because we want the current actor to turn or to face where whatever tile he has selected for a spell or an attack. So that's what this code is going to do. It just works out where he should be facing. Then we're going to create an instance of obj animation, which is what this is about. And then we're going to set the state of animate the action to take an action, which you haven't done yet. But just type it for now. You'll get a yellow mark there. Don't worry about it. We'll sort that out when we get to the actual object itself. And then we're going to set battle state to our new battle state, which is running action, so that no, we can't do any of the other stuff. That's what it's for. And then the rest of it's pretty much going to be inside OBJ animation. Just going to the draw event of OBJ test, and then draw cell, battle unit. So I've got it as line 1, 2, 3 because we're using a boolean instead of a state. We want to check that instead of this. So just make sure you've got this instead of that. So we're going to make 3 new scripts before we go into the OBJ animation to do the code. The first script is scr animate actor. We're going to pass it an instance ID, which is going to be one of the actors on our it's going to be one of the instances of OBJ actor, and what animation or what state do we want it to play. So passing it to 2 variables. It's going to run one of the other 3 scripts, which is what actually changes the state of the actor. I'll show you this script in a minute. Then we want to tell our test object to center on the actor, so it's not just playing randomly somewhere. And we also want to tell our animation object that it needs to wait for this animation to play, and which actor or which instance ID is the one playing the animation. Because the way it's going to work is when the queue runs a script, the script's going to tell an actor, okay, this is your new sprite. When the sprite gets to the last image, it's going to tell the animation object, okay, I've finished my animation. And then the animation object is going to tell the actor to change back to the idle or movement sprite, and then it's going to get the next list from the animation queue. So that's what this is about. If we go to scr change actor state, so all we do is we want to tell the actor to start from the first image. Make sure it's actually going to run the image. It's not like image speed of 0, which won't animate anything. Change the actor state. Work out which sprite. Well, first of all, get the sprite grid for the character, and then work out which sprite we should be changing the actor to. That's what this is for. And then the animation will play. When the animation is done, it tells the animation object, okay, I'm done. Next one, please. And then the other script is kind of similar to this one, and I was trying to use the same script for both, but because it's a node, it's not going to have a state. We just need to know the ID of the node. We don't need a second argument, but I have included one because it's just easier. I'll explain why a bit later on. We're going to give a sprite to the node, and then we're going to center on the node, and then this is the same as inside scr animate actor. Just tell the animation object to wait. And what's going to happen when we are drawing everything in the battle, we've got a little region that says, okay, does the node have a sprite? If it does, play it, and that's what's going to happen. Okay, so now we are going to code the animation object. If we go into the create event, we have a new entry in eAnimations, which is going to be take an action. So whenever we create the animation object in OBJ test and we want to play an animation, we're going to set the state to this, and we have a new enumerator for this state, which is eActions. We're going to have initialize, get next action, and wait for animation end. Initialize is going to fill the queue, our DS priority queue, with the lists that tell the game the animations to play. So which actor is affected, what state should they be in, that kind of thing. Then get next action is going to get the next list from that queue. While that's playing, we're going to be in this state, waiting for the animation to end. all that's going to happen is we're going to know the ID, the instance ID of the current actor playing an animation. As soon as the animation gets to the last image in the sprite, we're going to go back to get next action, or we're going to actually wait for a few seconds and then go back to get next action. And then if there's another list in the queue, play it. Otherwise, if the queue is empty, then we are done with the animations and we can destroy the object and continue with the battle. Action state is going to track these 3 states. Actor animating is going to hold the ID of the actor that we are animating, and that's as soon as this actor's image index gets to the end of the animation, then we are done with waiting for the animation to end. Animation queue is our queue which holds the lists of all the animations that we want to play. So then if we go into the step event of the animation object, we have a new region inside this if statement. So if the state is taking an action, then we have this region here. So this first region is going to be initializing. So if the action state is initialize, then this stuff's going to happen. So we're going to create a list. We're going to add to this list the script we want to run. We're going to add the actor we want to run it on, and the state that we want to change for this actor. That's what this line is going to do. And then we're going to add this list to our animation queue with this line. This is how we're going to build up our animations so they get played in order. And then we want to go through all the nodes that are stored in list of active nodes, because if you remember at this point in the game, the list of active nodes is going to hold the nodes that are affected by the AoE, the area of effect, regardless of whether it's just one tile or 20. And then this for loop, so let me just show you this. So this is the initialized region. We've got one big region to do, and then we're going to set the state, the action state, to get next action. So before we do that, we've got this big region here, which is all of this. And what we need to do is we're going to go through the whole list of active nodes and check them to see if there's an animation we need to play. If we're casting a spell, we want to see a spell effect on every tile. If there's an actor on the tile as well, then we want to see an animation for them. If it's not a spell, then it's only animations for actors that we are interested in. So the first thing we want to do is get the first node in the list. If it's a spell or there's an actor in that same cell as the node, then if it's a spell, make a list. To that list, we want to add the script we want to run, or we want to run the animate node script because it's a node. We're going to pass the ID of the node, and we just want to put -1 for the second argument because animate node only needs one argument, but to save on messing around, we're just going to pass it a second argument as well. And then we're just going to add this list to the animation queue. If there's an actor in that cell, there could be one there regardless of whether it's a spell or like a normal attack. Then again, create a list. To that list, add the script we want to run, the ID of the actor, and the animation of the actor we want to run, and then add that list to the queue. DS priority size animation queue is going to increase the more lists we add to it. That's why we can just use it as the priority. And then we just want to clear the list of active nodes so we're not keep drawing it from OBJ test. And that's that big region done here. And then like I said, we just set action state to get next action. So what this region's done, like I said, is we're just building a queue of lists, and each list holds a script we want to run, the actor or node we want to run it on, and the state for the actor if it's an actor. And then we have this here. So if action state equals get next action, then we want this region to run. If we still have a list to run, then the size of the queue is going to be greater than 0. So do this stuff. So get the list that we want. This also deletes it. This function here also deletes that list from the queue. Script is going to be the first argument. Argument 0 is going to be the second entry in the list. And argument 1 is going to be the third entry in the list. And we can use a useful function called script execute, which runs the script. We're passing it the 2 arguments. So this basically is the same as typing this script animate actor actor e actor dot attack. It's the same as this, but because there's different scripts we want to run, we're holding the script inside a variable, because this can be different scripts. So that's how and why it works. And then once we've passed the arguments to the script and run it, we can just destroy the list. We don't need it anymore. Otherwise, if the queue size is 0, then this is going to run. So we've played all the animations. We can tell obj test to get the next actor because they've had their turn, and then destroy the instance of the animation object. Otherwise, if action state does not equal get next action, then this will run. So we're waiting for the actor to finish their animation, basically, this region. This line's checking to see whether the actor has finished their animation. So if the image index is greater than or equal to image number -1, it's at the end of the sprite, basically. So if that's true, this is going to run. We're going to use a timer which starts at 0 to give us a bit of a pause between switching to the next animation. So to begin with, timer is going to equal 0. So this is going to run. It's only going to run for one step. This is checking to see whether it's a node or an actor. If it's a node, then the sprite index is going to be a spell animation. And then all we need to do, because the node is finished, we're just going to set the sprite index of the node to -1 and its image index to 0. Otherwise, it'll be an actor. So we're going to use our change actor state script. We're going to pass it the actor animating and the state we want to switch the actor back to. Then after this is run, we're going to increase timer. This is going to run for 20 steps, and then it's going to get to here. That's what gives us the pause between animations. And then we're just going to reset the timer to 0, and we're going to say action state equals eActions.getNext action. So we're going to grab the next action from the queue. And there's nothing in the draw event or draw GUI for obj animation, because we have obj test that draws everything via scripts. There is one more region that I left for the end. I thought it would make more sense to do it now rather than earlier. So back in the draw region of obj test, inside the draw cell region, just above where we draw the cursor, we have a new region called draw spell animation. And all we need to do is get the node from the current cell and check to see if that node has a sprite index of the spell animation. If it does, then we're trying to cast a spell. So all we need to do is draw it. And this, by doing it this way, it doesn't matter if there's like higher tiles in front of the spell, that kind of stuff. It will play, it will draw in the correct order. So we don't have any kind of problems with drawing things over tiles, that kind of stuff. And that's it. We should be able to run the game now. I haven't really tested items. Using items in this, that's going to be in the next episode where all the stats are going to be done. Hopefully other stuff as well. So for now we're just going to test to make sure we can attack and cast spells and stuff. So I'm going to move next to this guy, the knight, and use my attack option. And you can see the fighter played animation and the knight played their animation, and then we got sent to the next actor. If I go to another fighter, this guy here, and let's make him use a spell, and we're going to cast it here, so we affect 2 actors. So you can see, well, let me play that again actually. Let me get to a different, let's make this guy cast another spell. So we should see, if I cast it here, we should see 5 tiles animating and 1 actor being hit. It's 1, 2, 3, 4, 5. The reason the actor didn't animate is because he doesn't have an animation. Let's just cast it on the knight because he does have an animation. This guy here. 3. There we go. That's it. The animations, the sprites aren't great, but you can see it works. If you have, some really nice sprites, they'll work. It's just that I can't draw, so yeah, that's why. I hope you enjoyed the episode. Next time, like I said, we're gonna get into the stats and damaging and leveling up and stuff, making sure items work and stuff like that. But apart from that, I will catch you next time. Bye for now.